Hello and welcome back to the lab. Thanks for stopping in again, and for everybody who's new, thanks for joining. Today on the bench, this is going to be a presentation all about probes, starting with high voltage probes, and then going into meter connections, some high energy stuff, and a little bit of safety. I've been getting a lot of questions about high voltage probes and the high voltage measurements that I have to take when calibrating a scope, and why I still use the 8840 when I have a couple of other meters in the lab. So I do want to expand on that topic, and then also going to talk a little bit about finding replacement probes for meters that you might pick up on the secondary market. May not come with probes, especially some of the older style probes, and some of the cautions around there. So let's get into it. Right here on the bench is my Fluke 80K6. I believe this is a 6 kV probe. They do make two probes larger than this. This is actually the small one. I did check the 80K6 is good to 6 kV. So it's right in the nice sweet spot where I'm taking measurements on the scopes where I need to measure the 4,000 volt rail and things like that. This is not good enough to measure the anode discharge voltage to the front of the tube. So the way they get the brightness out of the scopes is they have a 4,000 volt supply, and then that hits a voltage tripler, sometimes higher than that. And I'll get a schematic out here in a second. And depending on the speed of the tube to get the brightness, they use an acceleration voltage to smash the electrons into the phosphor in the front of the CRT. And the higher that acceleration voltage is, the faster they smash into the phosphor, the brighter the tube is. Especially on some of the high bandwidth scopes, you can see 12, 21, 27. I think 27 kV is the highest I've seen on the anode. So they can get up there. Fortunately, we do not need to measure the 27,000 volt anode. I don't want to stick my fingers in 27 kV if I don't have to. So I'm glad I get to work at a more modest 4 kV, which is odd to say in and of itself. If you are not comfortable working on high voltage, do not work on high voltage. I have a extensive background in repair and maintenance and other things. I've worked around high voltage, high energy circuits. I've worked around circuits that quite literally could kill me and not try. So be very careful doing this. You are doing everything at your own risk. Always take care, especially if you need one of these probes, especially take care. You are dealing with some pretty angry voltages. So it can be done. It can be done safely, but know what you're doing. Ask questions. Get help. That can't be stressed enough. If you're at all unsure, please don't, and ask a ton of questions. And as always, caution is rule number 1. Okay, so here's a circuit diagram of what's in the high voltage probe. The way this actually works is the probe sets up a voltage divider with the meter's input impedance to not blow the front end of the meter when high voltages are measured. This part of the probe has a very massive resistor in it. That's all that's in there. Now, I'm touching up here. I'm going to clean this, especially when you get into high voltages, things start getting jumpy. That's what the shield is here. It's to keep things from running up here and then arcing to your hand. Never grab one of these probes here. Always behind the hand guard. The higher the probe is rated for, the wider this is going to be. That's to keep the operator separated from the voltage. So that is a safety thing. Do never modify any of this. Also make sure this is always clean. Oil and things like that can be conductive at these voltages. Plastic can be conductive at these voltages. Everything can be conductive at these voltages, and the potentials can get very jumpy. For the diagram, the probe would be this way. So this resistor, I've been using KiCad a little too much, so resistors are square to me now. Just something I had to get used to, but that's why it's drawn this way. The probe tip is up here, which is just the tip at the top of the probe. We go through the main voltage dropping resistor. Meter taps off here through this connector, and you'll note that right here, it says ground on the connector. Let's see if I can get the camera to focus on that. There's a GND on that tab. That always has to go to the low side of the meter because that is hooked to the ground clip of the probe. So you have the division resistor. Meter taps off at the bottom of the division resistor. We have the meter's input impedance, and then we have the low side of the meter and the ground clip. So meter input impedances can move a little bit, a couple of percent. This is a fixed resistor. It will drift over time, but other than that, it, quote, doesn't move. So finding the meter that's in inventory that has the closest to 10 megohms, it gives you the best division ratio, because this will change with meters a little bit, and I'll show that here in a bit. This will not. So if this is off, it throws this division ratio out. The readings will be a little off. Now, what are we talking about? A couple of percent on 1,000 volt, less than a percent on 1,000 volt. Does it matter? I can't make that decision. That's up to the operator and the task at hand. Since I've had my human fingers all over it, which have oils and everything in it, that can also cause problems with high impedance circuits in meters and things like that, especially some of the higher, more sensitive instruments. A fingerprint can ruin the accuracy, just a fingerprint on the board. Okay, to clean the probe, we just use some 99% isopropyl alcohol to cut the grease. And just wipe this down. Sure to get all the grease and oils and stuff off of the anything that's red, typically. The red parts are the ones that are contaminant sensitive, but we'll wipe down the whole thing just in case. Now I'll let that sit. I won't use it right away because I want all that alcohol to flash off, because obviously I don't want something to arc up through the alcohol, and then not only am I getting shocked, but I'm also on fire. So that would be a bad day. So definitely give it a chance to flash off. Okay, to test if a meter is good for doing high voltage measurements and voltage divider probes, we're looking for a meter input of 10 megohms. So I got my Fluke 8505. This is one of the older meters I have in the lab, but it still has some uses on the AC range that are... This is the best spec on the AC range for all the meters in the lab for high frequency. Not necessarily accuracy or anything like that, but I believe, if I remember correctly, this thing will measure up to 10 megahertz, which is pretty high for a bench DMM. So what we need to do is, I've had the 6500 warming up for a while, so it's ready to go. We'll kick this over to resistance measurements. Turn this on. And we have 99.99 megohms. So this is actually a very good candidate for using the high voltage probe. Actually, let me detrigger this so I know. Manual triggering mode. Change the range. Trigger the measurement. This one may actually be a very good candidate for my high voltage probe. I may need to switch meters. And that's actually what I wanted to show. So on the 10 volt range on this meter, on the 100 volt range, we're at 10 megohms. On the 10 volt range, it overflows. So it goes into even a higher impedance than 10 megohms. So using this on the 10 volt range would not work with the voltage divider. It would throw off the measurement. So this one has to be used on the 100 volt and 1K range because the input impedance changes. Same thing on the 6500. The input impedance can change depending on what ranges that you're in. I want to say it goes to a gig ohm in the low ranges, maybe. So and I'm sure if I go down, it's going to measuring, and it's back to 10 meg. So I don't know why this thing doesn't like, but actually that was pretty important too. At its lowest range, 1 volt range, which wouldn't work, it's at 9.2 meg ohms. Oh, I know why the 10 meg range on this one, or the 10 volt range on this one goes funny. Now I remember. So you have 9.2. So at the 1 volt range, that would be a bad voltage divider for bad voltage divider ratio, and your measurements would be off. So this one, 101K. Why this thing went weird on 10 volts. There's a odd thing with this meter. If you manually set the range to 10, DCV, 10 volts, and then you hit average, and filter. Yeah, if you have averaging and filtering turns on, watch how slow this measurement happens. There's a measurement. There's a measurement. So it's very slow, but it's 7.5 digits. But it's only 7.5 digits on the 10 volt range. Okay, so I've zoomed in on the 6500. I have the probes hooked up to the 8840, and we're in overflow. But if I go to the 20 volt range, we'll give it a second to catch up. Sorry, it's on the 200 volt range. So on the 20 volt range, it even the 8840 has a high input impedance. 12-ish, 9 meg ohms. If I go to the 200 volt range on the 8840, this is why I've been using this meter specifically. It is the closest I have to 10 meg ohms in the lab. That's the only reason. So anything that's close to 10 meg ohms is good, but I did this same measurement with the 7510 when I had it, and the 8840 at 200 volts gives me 10.000 meg ohms, so I can't ask for better. But it also gives me the 3 digits of resolution that I need for doing the high voltage measurement and not blowing the front end of the meter. Fortunately, the meter input impedance is the same, but I think I plugged it into the amps and ohms connector. When you're doing this, make sure it's on the volts connector so you're actually measuring the right input. I did the check again, and all the input impedances matched, so these share input impedance. But yeah, just make sure you're on the right connector. Okay, I've made some connections to one of my high voltage power supplies. This is a broken DC reference standard that it's off. It needs adjustment. But I need the 7510 to get this thing working again. but it'll put out 1,000 volts, which is what I need. I have an alligator clip running down to the tip of the high voltage probe. Nothing is on at the moment. So we can kick this up to the 1,000 volt range. We have a angry red light letting us know that we're into dangerous territory. Oh, that knob's off. Have to adjust that. The high voltage probe is hooked up, making sure the ground leg is on the meter ground. Ground clip was hooked up first, then the power connector, and then we kick this on. Give the meter a chance to stabilize. And this is what we get. So 0.9984 volts. You multiply that by 1,000. So what the meter's saying is 998.3. So that's how the probes, and that's how all the high voltage probes work. It's just a matter of what the division is and what their voltage ratings are. I definitely don't want to touch anything over here right now because, 900 volts. And we can even prove that by reversing the polarity, which is a neat trick this EDC can do. So now we have a negative 998 volts. So they work positive and negative. Both polarities are fine. It's just a matter of making sure the ground connection is hooked up first. Not hooking up the ground connection first can, you don't get the division effect and can damage equipment, damage people. So it cannot be stressed enough that that is something that needs doing. For those diving down the rabbit hole of creating a lab for themselves, looking at older gear on secondary market and a few other things, you may see inputs that look like this. These are a non-shrouded banana plug. You can also use forks, and I think, these are drilled, so they have the hole that'll go in. Depending on the use case, these will be very preferred or a real annoyance. For everyday use, meter probes, things like that, they're kind of annoying. For cal use, good connections, things like that, they're fine. The main problem is, this is a set of, actually this is my set of Fluke industrial probes that I use for high energy stuff. And these are, these can do Cat 3 and Cat 4. Yeah, Cat 4 up to 600 volts. I've never worked on Cat 4 stuff. I kind of top out at Cat 2, really. I don't like going past the breaker panel. But I have worked on high energy stuff, big industrial power. So when I'm working on the industrial power stuff, I'm kind of picky about what my probes are and what my meters are because I don't want something blowing up in my hand. But these have a couple of safety features in there, like you check the leads, these are fine. They have a white insulation jacket underneath the red and the black, so if any white starts showing through, the leads have been damaged and they've lost some of their withstanding resistance and need to be discarded and replaced. But if we look at the connections, these are shrouded banana jacks. So what these are for is when you're plugging and unplugging the leads from the meter, your fingers can come in contact with the connections as you're moving things around. So that's what the shroud is there for, is to protect you from inadvertently coming into contact with the circuit if you leave the probes connected while you're changing meters around. Moving meter leads while something's energized is always a bad practice. Try not to get into that habit. But some of this older gear, before we had some of those safety protocols and regulations in place, used unshrouded banana jacks or pin, and some of the Simpson stuff even uses pin jacks, which is it's a pin about yay long, and it just goes into the meter. ProbeMasters, this is one of their sets. They still make an unshrouded banana plug. So the good news is you can get meter leads for old meters. Wonderful. I've provided these to some people that I've helped get labs spun up and get some meters off the ground. My preference is the straight pin. I don't know why. I find the angled, especially if you're trying to do 4-wire stuff and things like that, these get in the way. I like straight pin. Just a personal preference. But on my handheld stuff, I like the 90-degree bend. So I'm a little weird, I guess. But ProbeMasters does have these available to purchase. You can just order. I will leave a link in the description. They have not sponsored this video. They are not sponsors of the channel. I just like their probes. However, I've moved away from these probes, and I've moved to another one of their product lines. So in the ProbeMaster world, these are the 8000 series leads. These are the 9000 series leads. So I use the 9000 series a lot more in the lab than I do the 8000 series. The neat thing about the 9000 series is they have a spring-loaded shroud, so the shroud will come out, will expose the plug. So I can even use these leads on this meter. I can use these leads on the Flukes. I can use these leads on the Keithleys. I can use these leads anywhere in the lab. They work. But that leaves me with this end. So if I'm plugging this into a power supply, that's great. But now what do I do? Well, this is where these get really cool. So we have this box. And I can mix and match test leads for whatever the task is at hand. So one of the main reasons that I absolutely love these 9000 series leads, if they'd stop tangling, that is one drawback, is if I'm measuring something with a whole bunch of power supply rails, I can grab a large alligator clip. There's my ground reference, and I can put a standard meter tip on the positive lead, and I can just clip this to the chassis, and with one hand I can go around and measure the power points. Of all the meter leads that I have, also it fits the Keithley stuff. These are some of the tips that came with the 7510. Because it's a banana jack, it just pops in. So it fits all the Keithley stuff too. I have, that's the other Keithley one. This is the ProbeMaster one, same thing, but they make a pin lead for it. I find myself in troubleshooting and doing the scope calibrations using this style the most. These are great for grabbing onto Tektronix test points, things like that. They just hang off. Uh-oh. Did one get burnt? May have to look into that. A little bit of crud right there I might have to deal with. But they just, and as you're working, you can just pop them in and out for whichever one you need. They have small alligator clips, large alligator clips, standard J-hook connectors, fork connectors. Come here. Fork connectors. They also have pin connectors for going on 0.1 inch headers. You can direct measure 0.1 inch headers. And they use the same interface as the logic analyzers. So uses the exact same thing as logic analyzer pins. And then spring hooks. These have been used rarely, but when I need them, they're an interesting use to pull me out of a jam. These are the Keithley versions, specifically. I wasn't a fan of these. I have never used these tips since I bought them. So yeah, between the two, the 8000 and the 9000, I use the 9000 quite a bit more, but I like them both. And here's some silicone meter lead wire. As I said about the Fluke probes, you can see the white, if the jacket's damaged, the white inner layer to let you know that the insulation resistance is degraded and needs to be replaced. For doing the high voltage measurements, I've made this is a red version of that same wire, but I've made just some alligator clips just in case I need to get into somewhere. So this is a set of alligator clips on actual meter leaded wire. Meter lead wire is very special. It's not very special, but it is a special wire that's designed to be incredibly flexible, not break. They do this by getting, let's see if I can strip some of this down. There's a lot of very fine conductors in meter wire. That's what helps keep the flexibility and the leads from breaking. But yeah, there's some of that, how that white will show through. And that's true on the green and the black and the red wire. Super flexible wire, very fine. Good stuff. I would be remiss if I did not discuss in this video high voltage scope probes. So, can you guess by looking at them which one is the high voltage probe? So one of these is a standard, this is the, one of these is a standard 10X probe, which is this one, the one marked in blue. The one that doesn't have any marking is actually a 200 megahertz 100X attenuator probe. So it extends the range of an oscilloscope. These are actually set. These will work on all the scopes that I have in the lab, the 10, the 7, the 4, the Rigol, all of them. But it extends the range of the scope from at a 1X of being 5 millivolts to 50 volts, or 5 volts. It extends it to 500 millivolts at the lowest end, 500 volts division at the high end. These work exactly the same way that the meter probe does. It attenuates the signal by a factor of 100. And because it has the coating ring on it, the little pin here, the scope knows that it's a 100X probe and will adjust the readouts and everything accordingly. Other than that, they function exactly the same way as a normal probe. I have one in the lab because I needed to work on one of the scopes. I needed to work on the high frequency switcher, and I was working around 400-ish volts, I think, if I remember correctly. It's been a while, but I did need a 100X probe. Don't need it often, really don't need it often, but when I do need it, it is the correct tool for the job. The one thing you have to note with the high voltage, high attenuation probes is they derate very quickly with frequency. So low frequency, they're good to their rated, 500, 1,000, 2,500 volts, whatever they're rated to. As you go up in frequency, so at 200 megahertz, this is not a 1,000 volt probe or a 500 volt probe. As you go up in the frequency, they derate voltage-wise very fast. So make sure you check the charts and the curves in the data sheet to get what that derating is, because especially as the frequency goes up, the insulation with holding resistance starts to break down, and you can get buzzed just by touching the cable if the conditions are right. So As a very wise person once told me, high voltage is fun, just don't get it on you. Thanks for stopping by the lab and taking a look at the high voltage primer video. This is a very high level overview of some of the high voltage cautions and safety that I use in the lab, and a couple of the probes and tools that I use for taking measurements and working on scopes and practically everything in the lab. So if there's any questions, comments, or concerns, I will be in the comments below. And as always, I will see everybody in the next video. More is on the way.